asked for. So for number 1, I'm going to expand. Right now I have a single logarithm with something inside. I have log base 3 of a cubed b square root of c. What's happening between these things inside is multiplication. So I know I can separate using addition. So I'm going to rewrite this as log base 3 of a cubed plus log base 3 of b plus log base 3 of the square root of c. And from here, I know that this is, I want it to be in expanded form. I don't want exponents in expanded form, so I want to take that 3 and I want to move it. I also don't want to have this square root because that's technically an exponent. So first I'm going to start with that. This first logarithm here is going to change to a log, I'm going to take that 3, I'm going to move it to be a coefficient instead. So I'm going to have 3 log base 3 of a. I just moved that exponent to be a coefficient. The second one is okay. That second logarithm is already good. It doesn't have any exponents. And then the third logarithm, I'm going to first, the last thing I do when I condense a logarithm is I change fraction exponents to roots. So when I'm expanding, I'm going to do the opposite. I'm going to take a root and change it to be a fraction exponent. So I'm going to rewrite this first as log base 3 of the square root of c is equivalent to c to the 1/2 power. So I just changed that square root to be 1/2. From here, to finish this, I'm going to move that exponent to be a coefficient instead. And my final answer is going to be, I have 3 log base 3 of a plus log base 3 of b plus 1/2 log base 3 of c. I just moved that 1/2 to be a coefficient instead of an exponent inside of the logarithm. And this is my final answer. Okay, for number 2, I want to condense. I want to do the opposite of what I just did. Always start with parentheses. Whatever's in parentheses, that's what you start with. So I'm going to start with log base 3 of x minus log base 3 of y. I'm going to condense those things. Since I see subtraction in between them, I know I can condense them using division. So to condense it into a single logarithm, I have log base 3 of what's in the first logarithm, x, divided by what's in the second logarithm, y. So I knew that subtraction meant I could condense with division. So I have log base 3 of x divided by y plus, in condensed form, I'm not allowed to have coefficients. So for this other logarithm, I'm going to take that coefficient and I'm going to make it a exponent of what's inside of the logarithm instead. So I'm going to rewrite this as log base 3 of z to the 5th power. I have to do that because I can't condense these two logarithms now that I have unless I did not have a coefficient for the second one. So I had to change that coefficient before I could bring these two new logarithms together. And I'm going to bring them together because they have the same base. There is addition in between, which means I can consolidate them by multiplying their insides. So I have log base 3 of x times z squared in the numerator, z to the 5th power in the numerator, and then in the denominator I'll have y. And that's what I get when I multiply x over y times z to the 5th power. This is a single logarithm by itself, no fraction exponents, no coefficients. It's finished. It's as consolidated as it can be, as condensed as it can be. For number 3, I want to expand. So I have log base a of the 4th root of xy divided by z squared. What's inside of the logarithm is the 4th root of xy divided by z squared. To expand this, the first thing I need to start by doing is I need to change this root to be a fraction exponent instead. So that, because I know how to move exponents to be coefficients instead, and I want coefficients in expanded form, not exponents. So I'm going to change this to be log base a of, I have xy divided by z squared raised to that is the 1/4 power that I'm raising to if I'm taking the 4th root. From here, I'm going to take this 1/4 as the exponent and I'm going to move it to be a coefficient instead. That's why I changed that root to an exponent, so I could move that exponent to be a coefficient instead. Now I have 1/4 times log base A of xy divided by z squared. Inside of this logarithm, I see division, which means I can separate using subtraction. So what I'm going to do is I'm going to leave the 1/4 on the outside, and I'll think about it later, but I'm going to distribute it at the end. Right now, I'm just going to separate what I have. So I see division. I'm going to separate with subtraction. I'm going to write log base A of the thing on the top, xy, minus log base A of the thing on the bottom, z squared. And I have, so that division that I saw inside, I use subtraction to separate. From here, I can separate this first logarithm a little bit more. So I can separate this a little bit more. I see multiplication between the things inside of that logarithm. And so I can separate using addition. So I have log base A of x plus log base A of y. I could separate that first logarithm to be these two logarithms added together. Then the second logarithm that I see here, this could be rewritten as, I want to take this exponent and I want to move it to be a coefficient instead. So I'm going to write 2 log base A of z because no exponents in expanded form. So I just rewrote it so that exponent was a coefficient instead. And now that everything inside of the brackets I have, everything inside is as expanded as it can be inside, I'm going to finish by distributing that 1/4. So I'm going to distribute the 1/4 to everything. I'm going to have 1/4 log base A of x plus 1/4 log base A of y minus 2/4. So 1/2 log base A of z. So 1/4 times 2 is 2/4, and I just simplify that to be 1/2. And that's it. If I look in my expanded form, I should have a single factor by itself inside of the logarithm, nothing being multiplied or divided inside, no exponents, just coefficients. So I'm finished. For number 4, I want to condense. First thing I'm going to start with is parentheses. This is inside of that logarithm. So what I want to do is I want to bring together log base A of x minus log base A of y. I know there is subtraction in between, which means I can bring them together, condense them using division. So I can write log base A of the thing inside the first one, x, divided by the thing inside the second one, y. So this is what I have. I have 3 log base A of x over y, plus log base A of 2x. And another thing I'm not allowed to have in condensed form, and what I have to take care of before I can bring these two logarithms together, is this coefficient of 3. So I'm going to move that 3, I'm going to move that 3 to be an exponent instead. I'm going to have log base A of 2x plus log base A of x over y cubed. I need to distribute that cubed to both the x and to the y. So really I have log base A of x cubed over y cubed plus log base A of 2x. And now when I consolidate these two logarithms with the same base, there is addition in between the two logarithms, so I can multiply the things inside to bring them together. And I have log base A of 2x times x cubed is 2x to the 4th power. There's 1x here and 3x's here being multiplied. That's a total of 4 x's. And then in the denominator, I have y cubed. And this is a single logarithm by itself with something inside, no fraction exponents, no coefficients, so I'm finished. For number 5, which expression is not equal to? Not equal to 5. So I need to find which one's not equal to 5. I can start with A and see, is that equal to 5 or not? When I don't see a base, I know the base is 10. So this is actually equivalent to, well, it's asking me, what do I have to raise 10 to get 10 to the 5th power? Remember, a logarithm is always an exponent. So it's what exponent do I need to raise 10 to get 10 to the 5th power? And that exponent is 5. So A is 5. For B, I have log of 10 to the 12th power over 10 to the 7th power. And I'm just going to simplify that to be log of 10 to the 12 minus 7 power. If I have two things with the same base being divided, I take their exponents and subtract them. That's where our logarithm properties come from. And then I have this becomes log of 10 to the 5th power. And I know that this base is 10. This is exactly what I just did, and I knew that was equal to 5, so B is equal to 5 as well. For number C, or letter C, I have log of 10 to the 9th power divided by log of 10 to the 4th power. This is not equivalent to log of 10 to the 9th power minus log of 10 to the 4th power. This is not a single log. There's two logarithms here. This is not what's inside of a single logarithm. It's two separate logarithms being divided. Division is not the same thing as subtraction. So this is not what that is equal to. This is, I can evaluate the top. So the top is actually equal to, what do I have to raise 10 to get 10 to the 9th power? That's 9. And in the bottom, it's what do I have to raise 10 to get 10 to the 4th power? And that's 4. 9 over 4 is not equal to 5. So this is the answer. This is the one that is not equal to 5. You can continue on to do the last one, but this here is equal to 9, and this here is equal to 4. 9 minus 4 is equal to 5, so this is also correct. I mean, that's also equal to 5, but it's not correct for the question because it's asking what's not equal. For number 6, the mistake here is similar to what we saw in the last number 5. I have log of x divided by log of 3 is not log of x divided by 3. I know if I see subtraction between two logarithms, then I can condense them with division inside, taking what's inside and dividing. But that is not true. Division of two logarithms does not equal a single log with division. So that's the mistake. This is the mistake here. Log of x divided by log of 3 is not equal to log of x divided by 3. Log of x minus log of 3 is equal to log of x divided by 3. When I see subtraction in between two logarithms, not division in between them, I can consolidate or condense using division inside with their insides. Okay, for number 7, if I invest $2,300 at 7.5% annual interest, how long will it take for me to double my money when interest is compounded continuously? It already gives us the formula. I don't need to figure that out, but this is the compound interest this is the compound interest formula for continuously compounded interest. I'm going to just rewrite this. A is equal to P times e to the RT power. I'm going to use that. What it's asking for me for is how long. How long means that I'm missing time. I need to figure out the time, which means I should have all of the other variables. So A is equal to, I want to double the value of my money. So I started with $2,300, which means double is $4,600. My principal, I just said, the initial amount was $2,300. The rate is based on the 7.5% annual interest. I know percent is out of 100, so that's 7.5 divided by 100, which is 0.075. That's all I need for this, so I'm just plugging in these values. I have 4,600 is equal to the principal, which is 2,300, times e to the 0.075 t power. The first thing I want to do, I need a base raised to an exponent on one side by itself for me to be able to solve this problem. Right now I have an extra 2,300 on the right-hand side that's being multiplied. I just want this base raised to this exponent by itself. So I'm going to divide by 2,300 on the right, and if I do that on the right, I have to do that on the left. 4,600 divided by 2,300 should be sorry, it's 2. Duh, because I doubled. And then I have 2 is equal to e to the 0.075t power. When I have a base exponential on one side by itself, I take the log of both sides. You could do the common log if you want, but the fastest way to do this is to take the log with the same base as the base that you see in that exponential. So I could do log base e of both sides. I'm going to take log base e of both sides. That's going to get me to the exponent as fast as I possibly can get there. So I have log base e of 2 is equal to log base e of e to the 0.075t power. And on the right-hand side, what this becomes is I'm asking, what do I have to raise e to get e to the 0.075t power? And that is 0.075t. On the other side, log base e is the same thing as ln, which I see in my calculator. So I'm going to rewrite this as ln of 2, which I can calculate just using my calculator. The last thing I'm going to do to get t by itself is divide by 0.075. I do that on both sides. And I get that t is equal to, when I do that, ln of 2 in my calculator divided by 0.075. And I get 9.242. 9.242. So it's 9.242 years it would take for me to double my money. For 8, Carrie is investing to save for a new phone. She invests $250 in an account for 5% interest compounded quarterly. When will she have the $900 she needs for the new iPhone? So first of all, I want to decide which one of the formulas I need. I have y is equal to a times b to the x power. I have a is equal to p times 1 plus r over n to the nt power. And I have a is equal to p times e to the rt power. This is compounded. It says compounded, so it's one of these two, because these are the compound interest formulas. This one is for continuous. This says quarterly, so that's a finite number of times per year that I'm compounding interest, which means I'm using this formula. So I'm going to write that down. A is equal to p times 1 plus r over n to the nt power. This is asking me when. It asks when, which means I'm missing time. Time is the thing that's missing, which makes sense because it's in the exponent, and I'm probably going to have to use the logarithm since we're working with logarithms, and if I need a logarithm, it's because I need to get the thing out of the exponent, the variable out of the exponent, and that's how I do it. I use logarithms. So I have t is equal to, question mark, I don't know. And I should know everything else. So A is what I want in the account. At the end, so I want $900 final, so I could buy that phone. P is the principal, what I started with, that's $250, so P is $250. I know the R is based on 5% interest. I need to say 5, that's a 5 out of 100, 5 divided by 100, which is 0.05. And then the number of times compounded per year is, it says quarterly, which means it's 4 times per year. And I just plug these numbers in. So I have 900 is equal to 250 times 1 plus, I have 0.05 divided by 4, to the 4t power. And from here, I want a single base by itself. This is my base raised to this exponent. That's what I want by itself on the right-hand side. So I need to get rid of this 250. I'm going to divide both sides by 250 to get rid of that 250 on the that's being multiplied on the right-hand side. 900 divided by 250 gives me 3.6. So I have 3.6 is equal to, I have 1 plus, I'm going to see what this is in parentheses. What is that base? 0.05 divided by 4 plus 1 gives me, it's 1.0125 to the 4t power is what I have after these cancel. From here, I have a single exponential on one side equal to a constant on the other. I'm going to take the common log of both sides. I could take the log base 1.0125. I think that might freak some of you out, so I'm just going to do the common log of both sides. That's going to get this variable out. The point of doing that is to get this variable out of the exponent. I want to get that variable out of the exponent by taking the log of the right-hand side. If I take the log of the right, I have to do that on the left as well. So I have log of 3.6 is equal to log of 1.0125 to the 4t power. This, because now this is a logarithm, I can take this exponent and I can move it to be a coefficient. Instead, I can move it out of the exponent place. So I have 4t times log of 1.0125 on the right-hand side is equal to log of 3.6 on the left. I can get t by itself on the right-hand side by dividing by 4, this extra 4, and this log that's being multiplied. So I can divide by 4 log 1.0125. Make sure if you do this in your calculator, if you don't do it separately, so you don't divide by log and then divide by 4, make sure you are using parentheses around your 4 log of 1.0125 in your calculator. So I should be getting, when I do this, t is equal to, I have log of 3.6 divided by, in parentheses, I need the parentheses. So I'm not dividing by 4 and then multiplying by a log of 1.0125 because that's what your calculator will do. So in parentheses, I write 4 log of 1.0125. And I will get, when I do that, 25.778. Make sure your answer makes sense when you get it. 25, this answer doesn't make sense because the situation is ridiculous, because you'd need 25 years to be able to afford that phone, and that by that time we probably won't even be using these kinds of phones anymore. Maybe we'll have like what is it called, holographic phones? I don't know. But the phone won't be $900 anymore at that point. You'll need more money than that. However, this does make sense based on the numbers that I had. All right, for number 9, I have 8 to the 2x plus 3 power is equal to 1/2 to the x plus 4 power. I have 2 exponentials, so both sides I have exponentials. I need to rewrite both sides in terms of the same base. So 8 and 1/2 share a base of 2 in common. They share a base of 2 in common. So I'm going to rewrite both sides in terms of 2. On the left, I can rewrite 8 as 2 to the 3rd power. So 8 is 2 to the 3rd power, and that's being raised to the 2x plus 3 power. On the right, I have 1/2 is the same as 2 to the negative 1st power. And I write this as 2 to the negative 1st power raised to the x plus 4 power. From here, I know I have a power to a power. That means I multiply, and I need to distribute that 3 to both the 2x and to the 3. I'll have 2 to the 6x, 3 times 2x is 6x, 3 times 3 is 9, so it's 2 to the 6x plus 9 power. And on the right-hand side, I need to distribute this negative 1 to both the x and to the y, and to the 4 I'm multiplying. And I will have 2 to the negative x minus 4 power. I know these two powers have to be equal to each other. I have to be raising 2 to the same power for the two sides to be equal. So I can write the equation 6x plus 9 is equal to negative x minus 4. And I can solve that equation. I'm going to add x on both sides. I'm going to get 7x plus 9 is equal to negative 4. From here, I'm going to subtract 9 on both sides. And I'm going to get 7x is equal to negative 13. Divide both sides by 7, and I get that x is equal to negative 13 over 7. Careful. Just because you have a negative answer doesn't mean it doesn't work. So I see some of you, when you see a negative answer, you say no solution. First of all, I don't have logarithms in the original equation that was given to me, so there's nothing for me to check. The only reason I check is if I have a negative or I have 2 different answers. I check because I want to see if what's inside of a logarithm is negative in the original thing that was given to me. I don't have any logarithms here. This is the correct answer. For number 10, I have a base raised to an exponent is equal to a constant. So what I do is I take the log of both sides. I'm going to take log base 5 of both sides. That will get me directly to that exponent on the left-hand side. So I have log base 5. I'm going to take of both sides. Log base 5. And I have on the left log base 5 of 5 to the x minus 2. And on the right, log base 5 of 8. Log base 5 of 5 to the x minus 2. I'm asking, what do I have to raise 5 to get 5 to the x minus 2 power? And that is x minus 2. On the right, I can change this using the change of base formula. I can write log of 8 divided by log of 5. The base goes in the bottom. Logarithm. The answer goes in the top. And then I just evaluate this in my calculator. So I have log of 8 divided by log of 5. And I get 1.292, and that's equal to x minus 2. I add 2 on both sides. I want to get that x by itself on the left. And I get that x is equal to 3.292 is my answer. All right, for number 11, I have log of 6 of log base 6 of n minus 2 plus log base 6 of n plus 3 is equal to 1. These two logarithms, they share a base in common. I can't do the steps before I get a single log by itself on one side or both sides. There are two logarithms on the left. I need to consolidate them into one. These logarithms share the same base, so I can condense them. And since there's addition in between, I can condense them with multiplication. So I can write log base 6 of, I have n minus 2 times n plus 3. And that's equal to 1. I'm going to simplify what's inside. So off to the side, I could do this. Whoops. N minus 2 times n plus 3 if I need to. N times n is n squared. N times 3 is 3n. Negative 2 times n is negative 2n. And then negative 2 times 3 is negative 6. So I have n squared plus n minus 6. And that's what I simplified the inside to be. And now I have a single log equal to a constant. I'm going to rewrite this in exponential form, just like last unit when I couldn't solve something. To get to the variables inside of the logarithm, I need to rewrite in exponential form. My base is 6, that's the subscript. I'm raising to the first power. The exponent is always the thing that's by itself on the opposite side. And then that's equal, And that's equal to the inside, which is n squared plus n minus 6. I have n squared plus n minus 6. I'm just going to simplify this to be, I have 6 is equal to n squared plus n minus 6. From here, this is a quadratic equation. I need to get all my terms to one side. I'm going to subtract 6 to get all my terms to the right-hand side. N squared plus n minus 12 is equal to 0 is what I get. I'm going to factor that right-hand side. I need two numbers that multiply to negative 12 and add up to positive 1. So two numbers that multiply to negative 12 and add up to 1. That's negative 3 and 4. So I have x minus 3 times x plus 4 is equal to 0. I have, that means x is 3 or x is negative 4, because one of these two things has to be equal to 0 for the product of them to be 0. Now, this is where I check to see if these two numbers work. If I plug in 3 here, if I plug into the original equation 3 for the n, why did I change it to, this is n minus, oopsies, this is n minus 3, n plus 4 is equal to 0, so n is equal to 3, or n is equal to negative 4. And for 3 works, these are both positive. If I have 3, they're positive inside of the logarithm, so that works. If I plug in negative 4 here, and it just has to not work for one of them, that's negative 6 inside, that doesn't work. So, because that's negative, and I can't have a negative in a logarithm, so the only answer is n is equal to 3. For 12, I have 2 times e to the x plus 3 power is equal to 64. This is a single logarithm equal to a constant, a single exponential equal to a constant, except it has a little extra on the left-hand side that's being multiplied. So I need to get that base raised to the exponent by itself by dividing by 2 on the left. If I do that on the left, I have to do that on the right. So I end up with e to the x plus 3 power is equal to 32. On both sides here, I'm going to take the log of both sides to get to that variable in the exponent. I want to get the exponent out of the exponent. So I'm going to take the log of both sides. In this case, since my base is e, it's easiest for me to take log base e of both sides. So log base e of the left and log base e of the right. I take log base e of e to the x plus 3 power and do log base e of 32. I end up with, on the left-hand side, I'm asking what do I have to raise e to get e to the x plus 3 power, and that is x plus 3. On the right-hand side, I really have log base e is the same as ln, so I write ln of 32. From here, I'm going to just evaluate what ln of 32 is in my calculator, and I'm going to subtract 3 from that. So I'm going to subtract 3 and see what I get. I do ln of 32 minus 3 in my calculator, and I get x is equal to 0.466, and that's my answer. For number 13, I have log of 5x minus 6 divided by log of x is equal to 2. If I see, I cannot change this to log of 5x minus 6 minus log of x. I can't do that, and also it wouldn't help me at all. I have to get rid of this log of x in the denominator, so I'm going to multiply by log of x. If I do that on the left, I have to do that on the right, multiply by log of x. I get, when I do that, on the left, I have these cancel, and I get log of 5x minus 6 is equal to 2 log of x. I want a single log equal to a single log. I want a single log equal to a single log, so I want to take this, right now I have I have a coefficient on the right-hand side. I need to move that to be an exponent instead, so I'm going to move it to be the exponent of the thing inside of the logarithm. Now I have log of 5x minus 6 is equal to log of x squared. I want to take what's inside of one logarithm and set it equal to what's inside of the other. What's inside needs to be the same for both of these logarithms with the same base for them to be equal to each other. So I have 5x minus 6 is equal to x squared is the equation I can write to solve from here. I'm going to get everything on one side because this is a quadratic equation. I'm going to subtract 5x and add 6 on both sides. Subtract 5x and add 6. I'm going to get 0 is equal to x squared minus 5x plus 6. From here, what I want to do is I want to factor the right-hand side. I need two numbers that multiply to 6 and add up to -5, and those numbers are -3 and -2. So I have x minus 3 times x minus 2 gives me 0, which means x is either equal to 3 or x is equal to 2 because one of these two things has to be equal to 0 for the product to be 0. So if I plug in 3 or 2, either one of those will be 0. I check to see if these work. I check to see if 3 is okay to have into, well, the two logarithms I have in the original are log of 5x minus 6 and log of x. If I plug in 3, it's okay for both of these. It gives me positive numbers inside of the logarithms. If I plug in 2, it's also okay in both of them. So both of these answers are answers, and I circle both of them. All right, for 14, I have log of x plus 5 minus log of 5 is equal to log of -3x. First thing I want to do is consolidate the left-hand side to be one single logarithm. So I know there's subtraction in between, which means I can divide what's inside. So I have log of x plus 5, what's in the first logarithm, divided by what's in the second logarithm, and that's equal to log of -3x. These two logarithms have the same base and they're equal to each other, which means their insides need to be equal. So I can write an equation, x plus 5 divided by 5 is equal to -3x. The insides are equal to each other. I'm going to multiply by 5 on the left-hand side, so 5 over 1 on the left-hand side to get rid of that 5 in the denominator. So I'm going to multiply the right-hand side by 5 as well. I have I have x plus 5 is equal to -15x. From here, I'm going to subtract x on both sides. And I'm going to end up with 5 is equal to -16x. I'm going to divide both sides by -16. And I'm going to get x is equal to -5 over 16. I'm going to check to see if that works. Does that work for all of the logarithms I have? And if I plugged it in here, this would be positive. If I plugged it in here, it would be positive. So this is a good answer. It doesn't make any of the logarithms negative inside. All right, for 15, I have 3 to the x plus 1 power is equal to 5. This is a single exponential on one side equal to a constant on the other. The easiest way to do this is take log base 3 of both sides. I'm going to take just the common log of both sides since I've been doing it the other way for the rest of these. I'm going to take the log of both sides. I have 3 to the x plus 1 power inside of that logarithm and 5 in the right logarithm. I just took the log of both sides. I did that because I wanted to get this exponent out of the exponent, and I can do that when I have a logarithm, an exponent in a logarithm. I can move it to be a coefficient instead. So I really have x plus 3, I put that in parentheses, times log of 3 is equal to log of 5. The first thing I'm going to do on both sides is I want to get to this x plus 1 by itself. So I want to divide by this log of 3 that's being multiplied. So divide by log of 3 on both sides. I end up with x plus 1 is equal to, I have log of 5, log of 5 divided by log of 3. I get 1.465, and then I subtract 1 on both sides. Is that right? And I get x is equal to 0.465, and that's my answer. Okay, for number 16, I have 2 logarithms with the same base, ln, so log base e on both sides, that are equal to each other, which means their insides need to be equal to each other. So I can write the equation, x plus 3 is equal to 2x plus 1. I'm going to solve for x, subtract x on both sides. I get 3 is equal to x plus 1. I'm going to subtract 1 on both sides. And I'm going to get x is equal to 2. So the answer is x is 2. I checked to see that that works in both of the logarithms. It does. The logarithms are positive inside. For number 17, I have log base 2 of x plus 2 plus log base 2 of x minus 1 is equal to 2. I'm going to consolidate these two logarithms with, I'm going to consolidate these two logarithms. There's addition in between. I'm going to consolidate them with multiplication. So I have log base 2 of x plus 2 times x minus 1. That's equal to 2. I simplify what's inside. X plus 2 times x minus 1. I do x times x is x squared. X times negative 1 is negative x. 2 times x is 2x. And 2 times negative 1 is negative 2. I have x squared plus x minus 2 inside. So I have log base 2 of x squared plus x minus 2 is equal to 2. From here, I have a single logarithm equal to a constant. I'm going to rewrite in exponential form to solve. I'm going to get this these variables that are inside outside of the logarithm. So I have 2 as the base. 2 raised to the second power gives me what's inside. 2 to the second power is x squared plus x minus 2. I have 4 is equal to x squared plus x minus 2. I'm going to get everything on one side, so I'm going to subtract 4 on the left-hand side, which means I'm going to subtract it on the right-hand side as well. I'm going to get 0 is equal to x squared plus x minus 6. I need 2 numbers that multiply to negative 6 and add up to 1, and those numbers are 6. Wait, no, what? Positive 3 and negative 2. So I have x plus 3 times x minus 2 gives me 0, which means x is negative 3. Or x is 2. And wait, let me just make sure that right because my brain isn't working. 3, 2, yes. I need to check these to make sure they work. So I'm going to check negative 3. If I plug in negative 3 here, oops, I have negative 1 inside of that logarithm, so that doesn't work. So x is equal to negative 3 is not an answer, and I'm going to cross it out. X is 2. 2 goes in here, and that's okay. That's 4 inside. 2 goes in here. That's a positive, so 2 is an answer for this problem. 18, I have log base 9 of x minus 5 is equal to log base 9 of 2x plus 13. I'm going to set these insides equal to each other. So I have x minus 5 is equal to 2x plus 13. I'm going to subtract x on both sides. I get, negative 5 is equal to x plus 13. I'm going to subtract 13 on both sides to get that x by itself on the right, and I get x is equal to negative 18. Now I have to check this to see if it works. So I'm going to check to see if it works, and if I plug in negative 18 into this first logarithm, unfortunately that's a negative inside of that logarithm, so this doesn't work. The answer is no solution. For number 19, I have log of x squared minus 1 minus log of x minus 1 is equal to 1. There's subtraction in between these two logarithms, so I'm going to consolidate them with division. I have x squared minus 1 in the top over x minus 1 in the bottom is equal to 1. I can simplify what's inside there. I have in the top, I have x plus 1 times x minus 1. I can rewrite x squared minus 1 as. In the bottom, I also have x minus 1, so I can cancel x minus 1 in the top and the bottom. From here, I'm going to have log of x plus 1 is equal to 1. I have a single logarithm equal to a constant. The base, if you don't see one, is 10. I'm going to rewrite this in exponential form. I have 10 to the first power gives me what's inside. 10 to the first power is x plus 1, so I have 10 is equal to x plus 1. I'm going to subtract 1 on both sides, and I'm going to get that x is equal to 9. So x is equal to 9. I check that to make sure it works. 9 squared minus 1, oh, that's positive. 9 minus 1 is positive, so that works. 20, I have 3 plus log base 12 of x plus 2 is equal to 7. I'm going to first start by subtracting 3 on both sides. I want to get a single logarithm equal to a constant on the other side. I have log base 12 of x plus 2 is equal to 4. From here, I'm going to rewrite in exponential form. This is my base 12. I'm raising it to the 4th power, and that gives me the inside x plus 2. 12 to the 4th power, 12 to the 4th power is 20,736 is equal to x plus 2. I subtract 2 on both sides, and I get my answer, which is x is equal to... I literally just did that on my calculator. That's so embarrassing. 20,734 is my answer. I checked to see that works. Oh, that's a positive number inside of the logarithm, so it's good. All right, and then for the last one, condensing and simplifying. So first thing I want to do is, in condensed form, I'm not allowed to have coefficients. I need to move that coefficient to be an exponent instead for what's inside of that logarithm. So I have really log base 2 of 5 squared, which is 25. For this logarithm, I'm going to factor that thing. So because I know that, actually, you know what, I'm not going to do that yet. So I have log base 2 of 2x squared plus 5x minus 3 minus log base 2 of x squared minus 9. There was nothing wrong with the other logarithms that prevented me from consolidating. Now I'm going to look at these first two logarithms and I'm going to condense them. There is addition in between, so I know I can condense them using multiplication. I'm not going to finish multiplying the things together. I'm just going to leave them as factors. 25 times 2x squared plus 5x minus 3 because, well, I know that there's some factors that I'm going to be able to cancel out. So I have that minus log base 2 of x squared minus 9. Now when I consolidate these two, I see subtraction in between, which means I know I'm going to be able to consolidate these two logarithms using division. So I have log base 2 of 25 times 2x squared plus 5x minus 3 all over x squared minus 9. And this looks factorable. This I know is factorable. I want to see if they share a factor in common, so I'm going to factor them. On the side, I'm going to do 2x squared plus 5x minus 3. I know I need two numbers. I need to turn this into expanded form, so I need to break down that 5x. I need two numbers that multiply to negative 3 times 2, which is negative 6, and add up to positive 5. And those two numbers are 6 and negative 1. So I have, this breaks down into 6x and negative x. So I have 2x squared plus 6x minus 3. And now I can see, using grouping, I can factor this because now it's 4 terms. So the first pair that I have, I'm going to take out the GCF, which is 2x. I have 2x times x plus 3. And for the second pair, I'm going to take out a -1. I have -1 times x plus 3. Now I've found they have a factor in common, x plus 3. So I have 2x minus 1 of x plus 3. So I have 2x minus 1 of x plus 3. And so that factors to be this. So hopefully you can see now that the top and bottom will share a factor in common. I have 2x minus 1 times x plus 3. In the bottom, x squared minus 9 is x plus 3 times x minus 3. That's the difference of two squares. These x plus 3's cancel, and my final answer is log base 2 of, I'm going to distribute that 25, to 50x minus 25 all over x minus 3, and this is my final answer.